In this part of the program, we're going to look at some of the more common equipment found on overhead distribution circuits. We'll look at the features that help you to identify the equipment, and we'll see where in a distribution system the equipment is typically found. One device we already talked a little about is the distribution transformer. It's cylindrical in shape, and because it steps primary voltage down to secondary voltage, it has different sized bushings. A distribution transformer has one or more larger bushings and several smaller bushings. The larger bushing insulates the transformer connection to the higher voltage primary circuit. The smaller bushings insulate the transformer connections to the lower voltage secondary circuit. The presence of two different sized bushings is a key feature to recognizing a distribution transformer. Overhead distribution transformers may be found anywhere on a distribution primary, wherever voltage needs to be stepped down to usable voltage for a customer. In rural areas where individual customers are far apart, a single transformer may supply power through a service drop to only one customer. In more populated areas, transformers may supply many customers through a secondary main with multiple service drops. Some customers require three-phase power. In this case, transformers may be banked together to provide three-phase power. A device that looks similar to a distribution transformer is the voltage regulator. Like a transformer, it's cylindrical in shape. Its function is to maintain voltage within a given range. If system conditions cause voltage to drop, the regulator brings it back up. If conditions cause voltage to rise, the regulator lowers it. There are several features of a voltage regulator that help to distinguish it from other overhead distribution equipment. One of these is the bushings. A single-phase voltage regulator typically has three primary bushings and no secondary bushings. One bushing insulates a phase source connection to the regulator. Another bushing insulates the regulator output connection to the phase. The third bushing insulates the regulator connection to ground or to another phase wire. A second identifying feature is a position indicator. Voltage regulators adjust voltage by moving a coil or by changing tap connections to a coil. The position indicator indicates the present coil or tap position. A third identifying feature is a control box on the side of the regulator tank or on the utility pole near the ground below the regulator. The controls are used to set the operating values of the regulator. Like distribution transformers, voltage regulators may be found anywhere on a distribution primary. Another device commonly found on overhead distribution poles is a capacitor. A capacitor is easily recognized by its square or rectangular shape. The number of bushings on a capacitor varies. The number of capacitors at a given location can also vary from a few capacitors to a bank of several capacitors. Capacitors can be found on any part of a distribution primary, but they're frequently located on circuits that feed inductive loads such as heavy-duty motors and air conditioners. The function of a capacitor is to improve power factor. This is done either by switching capacitors into a circuit to add capacitance to the lines, or by switching capacitors out of a circuit to remove capacitance from the lines. Distribution transformers, voltage regulators, and capacitors all keep the distribution system working efficiently and at the proper voltages. A variety of other pole-top equipment works to protect the distribution system. One of these protective devices is a recloser. A recloser is a switch that automatically opens and recloses a circuit when a fault occurs on that circuit. A single-phase recloser has a cylindrical tank, like a distribution transformer and a distribution voltage regulator. However, it has two primary bushings and no secondary bushings. It also has an operating handle so that it may be opened or closed manually, for example, to isolate a portion of line for maintenance. A three-phase recloser may look a little different. Here, it's a rectangular device with 3 pairs of bushings. It also has a single operating handle to open or close all 3 phases simultaneously. Reclosers are located along the main portions of a primary circuit, wherever the design or system requires the protection they provide. When a fault occurs, the appropriate recloser opens the circuit and interrupts fault current for a short period of time to allow the fault to clear. It then recloses the circuit to restore service. If the fault remains, the recloser will repeat the open-close operation several times. If the fault clears, the recloser will stay closed. If it doesn't, the recloser will eventually lock open. Another protective device, called a sectionalizer, is a switch that opens a faulted circuit after the circuit has been de-energized by a recloser or by another protective device, such as a substation circuit breaker. Sectionalizers look very similar to reclosers. The tank of a single-phase sectionalizer may be smaller than the tank of a single-phase recloser because most sectionalizers aren't designed to interrupt fault current. However, it's not always possible to tell a sectionalizer from a recloser by its size. Sometimes the only way to be sure is by looking at their nameplates. Sectionalizers are commonly used where a lateral is tapped off a feeder or where a branch line is tapped off a lateral. They're also usually coordinated with reclosers or other protective devices. When a sectionalizer operates, it will typically disconnect a smaller portion of a circuit than is disconnected by a recloser. Yet another protective device is the fused cutout. The fused cutout shown here includes an insulator, a contact and a connection point at each end of the insulator, and a fuse inside a fuse holder that connects the contacts and completes the circuit when the cutout is closed. When current exceeds the limit of the fuse will blow or break, causing the switch portion to fall open and disconnect the circuit. Fused cutouts can be used in a lot of places. They may be used where laterals or branch lines are tapped off a circuit. In this application, they would typically be coordinated with any sectionalizers and reclosers on the circuit. Fused cutouts may also be used in the circuit connections of distribution equipment to protect the equipment from excessive current from the line and to protect the line from excessive current from the equipment. A component sometimes used with fused cutouts is a current limiting device. A current limiting device protects system equipment by limiting current flow to the equipment during fault or short circuit conditions. Distribution equipment and lines may also be protected by surge arresters. A surge arrestor protects against damage from excessive voltage surges, such as surges caused by lightning or switching. An arrestor is typically mounted on or near the line or equipment it protects and is connected to the line at one end and to a ground at the other end. A static wire may be used in place of or in conjunction with surge arresters to help protect equipment and lines from lightning strikes. A static wire is a wire that runs along the top of distribution poles. It's connected to ground wires that run down the poles to ground. The static wire provides a cone of protection from lightning strikes for the distribution lines below it. One other device that should be mentioned is the gang-operated switches. This is a set of manually operated switches. A variety of switches like these are used in distribution systems to sectionalize circuits, to isolate portions of a circuit, to tie circuits together, and in general, to provide switching capabilities wherever they're needed.